A multimeter is one of the most important tools for any technician or DIY enthusiast, but it can also be one of the most confusing. There are so many different functions that a multimeter is capable of performing that it can be difficult to know how to use it properly. In this video, we will go over everything you need to know about using a multimeter, from the basics to more advanced functions. So if you want to learn how to use a multimeter, stay tuned. But before we get into the video, we'd like to take a moment to thank you all for your support. We wouldn't be able to make these videos without you, and we really appreciate it. Now let's get back to the video. The first thing you need to do when using a multimeter is to set it to the correct range. This is especially important when measuring voltage, current, and resistance. If you set the range too low, you may not be able to measure the full value of the signal. On the other hand, if you set the range too high, you could damage your multimeter. Let's start with voltage. The range you need to use depends on the voltage you're measuring. For example, if you're measuring the voltage of a battery, you only need to use a small range, such as 20 volts DC. But if you're measuring the voltage of a wall outlet, you need to use a higher range, such as 200 volts AC. When measuring current, you need to use an even smaller range than when measuring voltage. Most multimeters have a special low current range called the microamp range, which is used for measuring small currents in milliamps or microamps. Finally, when measuring resistance, you don't need to worry about the range as much. Most multimeters have a resistance range that goes up to at least 10 megohms, which is high enough to measure the resistance of most components. Once you've selected the correct range, it's time to connect your multimeter to the circuit. When measuring voltage, you need to connect the positive lead to the positive side of the circuit and the negative lead to the negative side. When measuring current, you need to break the circuit and insert the multimeter in series with the component you're measuring. When measuring resistance, you need to disconnect the power source and connect the multimeter in parallel with the component you're measuring. Now that you know how to connect your multimeter, let's go over some of its most common uses. One of the most basic uses of a multimeter is to measure voltage. This is useful for checking batteries, power supplies, and other circuits. To measure voltage, select the appropriate range and then connect the multimeter in parallel with the component you're measuring. The voltage will be displayed on the multimeter's screen. Another common use for a multimeter is measuring current. This is useful for checking fuses, circuit breakers, and other components that limit current flow. To measure current, select the appropriate range and then break the circuit and connect the multimeter in series with the component you're measuring. The current will be displayed on the multimeter's screen. Resistance is another important electrical property, and a multimeter can be used to measure it. This is useful for checking resistors, cables, and other components. To measure resistance, select the appropriate range and then connect the multimeter in parallel with the component you're measuring. The resistance will be displayed on the multimeter's screen. Multimeters can also be used to test diodes, transistors, and other semiconductor devices. A diode is a semiconductor device that allows current to pass through it in only one direction. A transistor is a semiconductor device that can be used as a switch or an amplifier. To test a diode, connect the multimeter leads to the diode's positive and negative terminals. If the diode is working properly, the multimeter should display a low resistance value in one direction and a high resistance value in the other direction. To test a transistor, connect the multimeter leads to the transistor's base, collector, and emitter pins. If the transistor is working properly, the multimeter should display a low resistance value between certain combinations of pins. In addition to testing individual components, multimeters can also be used to troubleshoot circuits. If a circuit isn't working properly, A multimeter can be used to identify broken components or faulty connections. For example, if a circuit isn't turning on, a multimeter can be used to check the voltage at the power supply. If the voltage is present, the multimeter can then be used to check for continuity in the rest of the circuit. Now that you know how to use a multimeter for basic circuit analysis, let's explore some more advanced uses. One of the more challenging aspects of using a multimeter is understanding the different types of measurements it can make. Let's take a closer look at each type of measurement and see how to use it effectively. AC and DC measurements are used to measure alternating current and direct current respectively. The main difference between the two types of measurements is that AC is a waveform that periodically reverses direction, while DC flows in only one direction. Multimeters typically have separate buttons or ranges for measuring AC and DC voltage and current. When using a multimeter to measure AC or DC, make sure to select the appropriate range and connect the multimeter in parallel with the component you're measuring. Ohms measurements are used to measure resistance, which is the opposition to the flow of electric current. Resistance is measured in ohms, which are represented by the omega symbol. To use a multimeter to measure ohms, select the appropriate range and connect the multimeter in parallel with the component you're measuring. Continuity testing is used to check for a complete path between 2 points in a circuit. A multimeter can be used to test continuity by putting its leads on either side of a component or connection. If the multimeter beeps or displays a low resistance value, then there is a continuous path between the 2 points. This is a helpful feature for troubleshooting circuits or making sure that a component is working properly. Capacitance is a measure of a component's ability to store an electrical charge. Capacitors are components that store electrical charge, and they are measured in farads. A multimeter with capacitance measurement capabilities can be used to measure the value of a capacitor by connecting its leads across the capacitor's terminals. Frequency is a measure of the number of cycles of a waveform that occur in 1 second. It's measured in hertz and is often used when working with AC circuits. A multimeter with frequency measurement capabilities can be used to measure the frequency of a waveform by connecting its leads in parallel with the circuit containing the waveform. Period is the amount of time it takes for one cycle of a waveform to occur and is the reciprocal of frequency. It's measured in seconds and is often used when working with AC circuits. A multimeter with period measurement capabilities can be used to measure the period of a waveform by connecting its leads in parallel with the circuit containing the waveform. Duty cycle is the percentage of a waveform that is above a certain threshold and is often used when working with PWM signals. A multimeter with duty cycle measurement capabilities can be used to measure the duty cycle of a waveform by connecting its leads in parallel with the circuit containing the waveform. Now that you understand the different types of measurements a multimeter can make, let's look at some examples of how to use it in various situations. Checking a circuit breaker is a simple task that can be made easier with a multimeter. To check a circuit breaker, use a multimeter to measure the voltage on both sides of the circuit breaker. If the voltage is present on one side but not the other, then the circuit breaker is open and needs to be replaced. Checking a fuse is similar to checking a circuit breaker, but requires you to measure the resistance instead of voltage. To check a fuse, use a multimeter to measure the resistance between the fuse's 2 terminals. If the resistance is very low, then the fuse is good. But if the resistance is very high, then the fuse is blown and needs to be replaced. Checking a relay is another simple task that can be made easier with a multimeter. To check a relay, use a multimeter to measure the voltage and current on both sides of the relay. If the voltage and current are present on one side, but not the other, then the relay is closed and working properly. These are just a few examples of how a multimeter can be used to troubleshoot circuits. With a little practice, you'll be able to use a multimeter to diagnose and repair most electronic devices. We hope you enjoyed this video and learned something new about how to use a multimeter. If you did, please leave us a like and comment below to let us know what you want to see next. And if you haven't already, be sure to subscribe so you don't miss out on our future videos. Thanks for watching.